Hey guys, welcome to Go Programming. Today we're gonna make something with Go, which is a kind of a new language by Google, and it's made by some of the guys who made C. So they try to fix some of the issues with C. It's a nice little language, and I'm only beginning to learn how to use it, as we will see in the video. But let's make something. Something usable. Let's try to solve a problem here. The problem I want to solve is one that I always solve with PHP, which is obviously not as fast. Great, so let's get into it. What I want to make is a HTTP server that responds nicely to requests like these. Standard request for a static file page, but I also wanted to respond nicely to this, and maybe something like this, the modern URLs. So let's see if we can do that. What happened here? Okay, so these are the requests. Great, do not save that. What I have set up here is a Go workspace. I've set it up in my Google Drive in a folder called workspace_go. This is how they specified on the website over here how it's supposed to be done. But I think I haven't seen an IDE that actually sets it up like this. Which is why we're just going to use the command line I've specified here. It's in the same folder as my Pathfinder over here. Great, we can list the files. Awesome. Maybe I should mention just briefly that I have Go installed, which allows me to use the Go keyword on the command line like this. If you don't have it, you can just install it. They have a Windows installer, it's really easy. Great. So let's go into the source package here and create a new package. I'm gonna go hydrozoa.youtube, and then we're gonna make a web server. Inside this package, we are going to make a new file here. main.go, then and delete the new text document. There we go. We have a main Go file. Awesome. I'm using Notepad ++ here. I have a syntax highlighting set for Go, I believe. Language Go. There we go. If you want this, you can install it like this. Go to your app data and then go to Notepad ++, and then inside the user defined language, you post this. I will link this in the description, but this is some basic syntax highlighting. Awesome. Let's get started with the coding here. Let's start with the hello world. Just get it running. Since this is a program, we're gonna specify package main, and I also want to import the formatter, since we are going to be printing to the command line, and then the main function, which is the entry point of the program. Now we're going to print something really fast here. Oh, we don't need the semicolons to specify that our lines have ended. So you'll see this language has really nice clean syntax. Let's just go hello world. We can try to run it from the command line with the go build. No, I think, well, let's see. Go build compiles packages and dependencies, and the install will compile and install packages and dependencies. Great. So we're going to use go install, and then it was hydrozoa YouTube, and then web server, and we just specify the directory here, and it will find the main file and the main function and go from there. Great, it compiled with no errors. Then we're gonna use just regular Windows syntax here to run the file, because if we go back to the workspace, my source here has just been compiled to a binary, and the binary is an exe. I've compiled it to run on Windows, and so it will be a Windows executable, and it is actually compiled, as far as I understand, to machine code, which is something very nice about this. It does not run inside a virtual machine like Java does. Great, so we can just run it like any other executable, and we got the result down here. Hello world. Great, we are in business. All right, we are going to start listening on a port for the HTTP protocol, and Go makes this really easy for us. Has in its standard library a package called HTTP, I believe. No, it's not called HTTP. It's a sub package of the net package called HTTP, and it contains some really nice functions for doing this kind of work. Great, so inside the HTTP package we can call this function called listen and serve. Great, let's find it over here while we're using it. The HTTP sub package of net, go into that, and then we want to go down to the index and find the listen and serve function. Maybe we can just do this, it's going to be easier. Listen and serve up here, function listen and serve. Awesome, great. So this takes a string address and a handler as a parameter. However, if we don't want to specify a handler, we can just go nil, like the Java null. The address is going to be localhost, so we don't specify anything, and then the port, I want to listen on 8001, since I don't want to interfere with my regular port 80 traffic, since I'm going to be looking up the documentation as we go along. Great. Now this listen and serve will never return. So once we reach this line, it's game over for our server here. But we can do something in the HTTP package before we do that, and that is we can specify a handle function. Great. You'll notice that the example over here for the listen and serve function also has a handle function, and it shows us how to use it. So the first parameter is the pattern that we want to match. So let's match home, and then the second parameter is a function for the handler, for where we want to the function we want to handle the request, and we can just say, let's make a new function here, request handler. Awesome. However, this handle function is not it's just not any function that we can throw into that. It has to be a function with the signature response writer, and then a pointer to a request, which is not the request itself. It's a pointer to the memory where the request is stored. But we don't really have to consider a lot of technicalities about this. We just need to understand that it's a pointer. All right, so let's copy this signature. We need to specify it. We're still inside the HTTP package, so the response writer is going to be the HTTP one, and the same with the request. Great. So now we have a request handler. Awesome. Now let's try it out. Let's print go hello world, when we get a request that matches our pattern. Just maintaining that it works. Compiles fine. Awesome. And it's running. You'll see that it never returns. See, since it's made it to this list and serve function. Awesome. So let's go localhost. When we just specify nothing more than the localhost and the port, we get a 404. That is because we are listening on this specific pattern. So if we don't match that pattern, then nothing happens because we don't have a function that matches that pattern. Our request handler here only matches home. So let's try to match it, and then we get hello world. So our server has seen we got a request. It was the right one for the pattern over here, so our request handler is going to do it. So you can one way to set up a server for different URLs is to use this handle function, but we're not going to do that today. But I showed you how that works. We're going to match any pattern. So when I do this, it says hello world. But if I delete that, still going to get a 404. Why? Oh, because we didn't reset the program, of course. Need to compile again. Great, and run. And now we should be, yeah, hello world. We can use any path and any parameters. Let's go with a Q searching terms. See, great. Okay. Now we get these parameters over here. Let's name them. Let's name the response writer W and the request R. You'll notice this is kind of foreign, that the typing is always after the naming of a variable. So it's a little bit different, but it's not too bad. Now we want to specify that a request has been made, and then maybe print some of the contents of the request. Great, so we know how to print a line, but now it's this request object. We don't know a lot about it, so let's go into the documentation again here, and we'll see. Oh, that's a bad way to do it. All the way up and then into index, and then we'll see this type request. Now Go has it's not really object oriented, but you can have these types. There's two different types. There's struct and there's interface. And struct kind of works like an object, but you can't. Struct is strictly only a collection of fields, and so you can't have a method inside a struct, but you can still have a method that can only be used in reference to a struct. So that's, yeah, but we're not going to do that this video. We're just going to see here that the request struct has a method string. Now this first letter here denotes that it's a public member, so we can use that to get the method, the request method. Let's do that. Let's indent a tab and then say method. And then over here on the R object we can point to method. We can do the same for some other fields, maybe let's see, the path. But how do we get that? We don't have access to a path in here. So how do we do that? Oh, request URI, maybe we do, and an unmodified request URI of the request line. Let's do that. Let's see what that gets us, right? What I want to do in this method is react to what request has been made, so that we can react to the different different kinds of requests. So we don't just serve static files, but we also get some nice URLs. Instead of having this method, we get the request URI and then get it from there. Awesome. Let's try to run this and see what we get. Okay, if I just attack the root, then I get a get method. All of these are going to be get methods when we do it this way. Then the request URI is going to be just a slash. What if I go hello? The request URI is going to be hello. What if I do help equals true? Oh, okay. So that also goes into the request URI. But I can actually make Go do a little bit more work for me than this, because if I just took this request URI and worked with that, then I would have to parse the string by myself, and I would rather like the file and then the variables in a map, preferably. So let's see if we can do that. Inside the request here is also a URL that we can modify, or access rather. So let's see what's inside the URL. You'll notice this URL is of type URL, which lives inside the URL package. So let's see what is inside this struct URL type. Ooh, it has a scheme, it has a path and a query. I think it's the raw query that it's not the raw query, it's the path. URL path. Let's try that. What is the path versus the request URI? Let's try. And running again here, and we are good to go. We still got the same request URI, but our path only specifies the file. If I make another slash there, it's not gonna be an issue. It's just gonna append the extra slash to the path here. Okay, that's fine. And then the raw query, I bet, is the variables. Let's see. Or the raw query rather. Raw query, okay. Great, let's try again. Yes, the raw query is the help equals true. What if we make more variables and searching equals true? Okay, so now we split the file requested from the query executed on that file. That's great. We can use that. All right. Let me just let's print a separator here. This is just info about the request being made. Okay, let's serve some files over this server here. So for that, we are going to think inside the workspace, since this is where I run my program from. I'm going to make a new folder here called website, and website's gonna have a document. Let me just fast forward and get this document straight. Okay, I created this small index file here, which we will now serve on any request using our web server. You can see what it looks like in here. This is the simple HTML5 document, or even HTML. I don't know if this is especially 5. Okay. Great. So from inside our document here, we need a way to know what directory we're serving files from. In this case, it's the website, but it would be nice if we could specify this at the command line, since this is compiled and we can't edit it once it's compiled. So let's make it read a command line argument specifying the directory that we want to use as root on our web server. For that, we need to import the package OS. Great, and we can follow along over here with the packages OS. Where are you? Down here. Great, so there's some system access here. Now Go does compile to both Mac and Linux and Windows, so you can't access Windows only features in here, but you can access what you need for general tasks. If you want to access the Windows API, you can, but I'm not going to show you how in this video. It's a longer story. Great, so these command line arguments, how do we read them? From the OS package, we get the function arguments. I thought maybe it's a variable. Args hold the command line arguments, so it's right here. Okay, it's a variable. Fair enough. And it's an array. Now the first, the 0th argument here is going to be our program's name. We'll see when we run from the command line that the first argument is going to be this bin/webserver. So that's not what we want to use. We want the second argument, which is on the first position here, and that's stored in a variable. Okay, so there's 2 ways you can do this in Go. You can either do variable and then go the name and then the type string, like that, and then you can assign it like that. That would work. However, if you don't want to do that, you can just do the colon equals syntax, which will initialize the variable of the correct type. This does have the disadvantage of it. You can't read the type from this, but the code is shorter and it's simpler. So that's the trade-off you get. I like to use this, so yeah. Right, now we read the first argument, and let's store it in a variable that is global. So actually we are going to do that. Use that syntax. Variable side path string. And then we should be able to just use the assign equals operator there. Okay, let's try. Great. Now on the HTTP response writer here, we have a few options. We can write, or we can write a header. So let's go back to our documentation here. HTTP, where are you? Here. And then response writer. Get this struct response writer. Oh, it's not a struct, it's an interface. Okay, so it has methods without implementations. That's the difference between an interface and a struct. Great, so we have this header object, and we have write and write header. Great, so this write header function is going to write the HTTP header. So for OK, it should just be 200. We can choose to to always send 200 back. Let's do that. Great. Oh, we have an error here. A index out of range. Oh, okay. So that's the site path here, because we read the second command line argument and we're not specifying any. So let's give it some website / since it's a directory, and now it runs. Awesome. Great. So we should have a server here that will return okay no matter what. Help. See, now nothing happens in Chrome. This is when we get a response 200. It's the response okay. Let's try to send a 404 back all the time. Oh. And now you'll see that no matter what I ask for, we get a 404 back. Now, how are you supposed to know these return codes? Well, it's in the HTTP spec, or they're built in to this HTTP package as well, so you don't have to know. You can just go in here, see status OK is 200, and we can find a 404 down here, status not found. So if we want to make this code readable, we can specify like this, status OK. We just reference the constant in our package here, in our HTTP package. Great, so now we wrote a header. Let's write some content to the page too. See, how are we doing on time? Okay. Yeah, so still we're working with the response writer. We get this right. Okay, so it has an argument that is a slice of byte, and then it returns an int and an error. In Go you can return multiple types at the same time, different fields of different types at the same time from one function. Very, very nice, and we'll see why. So we get to write this code in a nice way. Okay, so we need a slice of byte that we can put in this write function. Okay, so let's read our document here, our index. Before we do the write. For that we need the IOUtil package. Just gonna make a new fan here. New tab. Go into packages, and then we get this. We have the package IO that holds a lot of functionality, and the util, which makes it all really simple and really easy to use. So let's import that. IOUtil. There we go. It has this function, read file. Yeah, read file. Here. Great. IOUtil read file, and then you just have to specify file name. Since we know what path we're going to be serving our static files from, we can use the path up here and then just append the index HTML. I believe it was an HTML. It is an HTML. Okay, great. And then we get to read it into this object. Now notice that I also initialize these variables because we haven't specified what these are before. So now we're inferring it from this read file. So the bytes here is going to be a slice of byte, and then the error is going to be an error. Okay? Great. Now get to see the if structure now. This makes for very nice error handling, because this read file can throw an error. So afterwards we can just say if the error is something, then there's an error. So now we can so now we can check if something happened to our file reading. If it did, just return. So now we have a slice of byte called bytes with our bytes from the index file in. If we go back to the response writer, this write needed a slice of byte, so we can use this bytes. Great, that should be it. Let's compile it and let's run it. See, no matter what the request is, we always get this index HTML. Great. Now let's try to actually make the path have a impact on what file we're serving. Now instead of using the static index HTML, we can use the path from up here. So that was r.url pointing to the URL struct, and then the path. And if there is an error, then this time we can throw a status not found, and then return. But if we make it, we get to write status OK and then serve the file. So now what this is a static file server that will just serve whatever file you're pointing to. We run. Great, so now the index will work, but if we try to get index.png, we're going to get a 404 or a com. Okay, so what I wanted to do is also handle this case here and not throw a 404 on that, so that you can make your web server have these nice URLs. So if there's an error reading the file, we are not just going to return a status not found. We are let's try to look for a file, for an HTML file with this name in this case, so that this case would serve the index.html file, and this would serve a hello.html file. Great, so we use the same procedure here where we just look for no, let's not do that actually. Let's do something else. We can assign the path to a variable first, because the path can be a bit dirty. You see over here it can have a leading slash, and it can also have a trailing slash. So we should do something. It could also have consist of multiple different words divided by slashes. So we should definitely do something about this, right? What we know from Java and PHP is that we can just use a split, and that is the strategy I'm going to go for here as well. We are going to import the strings package, and then let's remove the leading slash over here. Strings, and then the function is trim suffix. And again, you can go inside the documentation and find that. I'm not going to do that this time though. So you'll just have to believe me. This will take the original string and then what you want to trim from the suffix. If there is no pattern matching this argument, then it will just return it as it is. Now we can assign path to the result of this method, and we can split it just like I said before, but then the path variable would change types. So what we're going to do is we're going to make a new type called tokens and assign it to strings, and I believe it's split. The string that we want to split, and then the second parameter is what we want to split it by. Great. Let's print these tokens here so we can have an understanding of what's going on, what we get with this tokens variable. I can say that the split function over here will spit out a slice of strings. So that's kind of like an array of strings, and we can access them like we would access an array. So let's try over here, compile, run. For a query like hello test, we get a hello and a test. Oh, we get a space, hello and test. Oh, that's suffix. This should be prefix. Let's try again. Now we run the same query and we get a hello and a test and a space. And the last space is because of the trailing slash over here. If we remove it, we see we don't get it anymore. This doesn't really matter for what I am about to implement, but if you want, you can trim the suffix as well. That would be a bit cleaner, but I'm not going to do it. Great. So I'm going to make this an if statement here, and then check if there's only a single token. That means we got to request something like this with just the hello. No, wait, it wouldn't because of the trailing slash. Okay, let's remove it. Trim prefix and suffix and split. Okay, so now a slice of string with a length of 0 would mean that we got a request that looks like this, or this for that matter, or this. But in that case, it wouldn't have made it that far. It would have just read here. Okay. If the length of tokens is 1 and our I think you can just use 1 ampersand. Let's try, and if it compiles, that's great. And the 0th index of token, no, we don't. Yeah, no, we don't. Okay, if it's a 1 length token, let's try to read the file again. But this time we append HTML, and so we go for the site path, and then append the 0th token, and then append the file type. So in this case we would be looking at the token.html. So over here we would be looking at, in this case, hello.html. Again, just like we did over here, we can do this and say if the error is not null, then there's an error. Okay, we can also say if let's see, we can do something clever with this, I believe. It is not exist function inside the OS package is not exist, and it takes an error as an argument. So if this error is a does not exist error, then this block's gonna run. And if that's the case, then we just make a status not found header and return. If we get more than one token, we also write the header not found and return. What happens down here? Yeah, this is the regular status not found, so that should be there as well. Great. However, in the case that we actually find the file we're looking for through this weird method, we actually want to write it to the client, write the status OK and the bytes from the file. Awesome. Oh, and we should also return there. Alright, I believe we are ready. So let's try to compile it. It does compile with a single ampersand. No, it doesn't. No, okay, it doesn't matter. We didn't check it. Okay, that's fine. Let's run it and go for the hello request. That's a 404. Okay, does that make sense? Inside a website we only have in index HTML. So let's try index. It works. Awesome. What if we drop the trailing slash? It also works. What if we request it like that? It also works. Okay, nice. What if we find a picture of a banana? Can we serve that from our save image as into the website here? Let's just go banana. Great, now we have a banana. What if I request this banana? I got it, man. Alright, so that's it. That's a very simple HTML, no, not HTML, HTTP server in Go. I hope you can see how easy that was, even though I'm not the best at this language. This is new for me too, but I am definitely changing the websites that I have set up with almost the exact same code just for PHP. I'm definitely changing it over to Go because that does run faster and it is compiled directly for the machine. Alright, thank you for watching my video.